Hello students, in this video we'll be solving one of the toughest class 9 standard board exam question recommended by the students. Many students face bit difficulty in solving this problem. So let us try to solve this problem. The question is on the screen. It was the 31st question of the board exam paper. Okay, so very typical figure. Okay, and there are some three angles to find it. One is angle APB, ADB, and OAB. So in this problem as well, we have to know few theorems which we came across in circle chapter of class 9 standard. Okay. So in this question, they give only one angle, which is that angle that is ACB is given. Related to that, one theorem we have been came across. What's the theorem? Okay. Angles lying the same segment of circle are equal. Like for example, purpose, this is our circle and this is the chord. Okay, and these are the angles bisected by the chord. So we should give the name for this one as angle 1 and otherwise this is the angle 2. As you can see, okay, angle 1, this angle 1 and angle 2 are in the same segment, Okay, if you don't have an idea of a segment, let us see. This is the chord. So this is our segment. This is also the segment. But this upper part we call it as a major segment. This below part we call it as a minor segment. And the example I gave you of 1 and 2 angle, those angles are lying in the major segment. And angles lying the same segment are equals. Okay, as you can see in the question, they give you ACB. One is ACB and other one is APB, this angle. They both are lying in the same segment. So we can say that is angle APB is equal to 40 degree. Reason we had write down angles in the same segment are equal. Same segment of circle are equal. Okay, out of 3, 1 we got it. Okay, other one. Okay, initially how we can write, we can write ACB is equal to APB. And this reason we can write it here as well. Same reason. And next to that we can write APB is equal to 40. Okay, so moving to the next angle, that is ADB. Now, how to find out ADB? Okay, as you can see, this A, B, C, and D. These are the 4 vertices which are lying on the circle. If the 4 vertices are lying on the circle, okay, it can be called as what, cyclic quadrilateral, because A, B, C, D is one of the quadrilateral. And that quadrilateral we can call it as a cyclic quadrilateral because the vertices of the quadrilateral is lying on the circle. So which are those vertices? A, B, C, and D. Related to that cyclic quadrilateral, there is one statement, that is theorem. What is that statement? Okay, we have came across that in the circle chapter. What's that, Okay, the opposite angles of cyclic quadrilateral. The sum of opposite angles of cyclic quadrilateral is equal to 180. So which are those opposite angles? One is angle A and angle B, which we are not at all concerned of, right? So our concern is related to D, and related to D, which is at the opposite angle C. C and D are opposite, and the sum of these two will be equal to how much? 180. So what is the name of those angles? I can say ACB, and what is the name of the angle D? We can give that is ADB. The sum of these two angles is equal to 180. The same reason, sum of opposite angles of cyclic quadrilateral is equal to 180. ACB value, we know that is 40. ADB, we don't know. We're going to write down as it is. ADB is equal to 180. Transpose 40 to the right hand side. That is ADB is equal to 180 minus 40. 180 minus 40 will get the values how much? 140. Right. Yes. So angle ADB is equal to 140. We got second angle also, we got it. This is ADB. Okay, let us find out the third and the last one. And that is bit difficult to find out. Let's see how to find out. Related to that, we have one more theorem. What's the statement of the theorem? Let us listen. The angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Okay, for example purpose, once again, this is our circle, this is our center. Okay, now this our radius. This is one angle which is lying on the part of the circle. Okay, so this angle and this angle we can compare it using the theorem. Like for example, the angle at the circle is 30. That means at the center it will be how much? Twice. Twice means how much? 60. That is what the theorem says. Okay. Angle which is formed at any point on the circle here, this one. AO. Okay, and one is this D. D. Okay. So let us erase this one. Okay. But we are going to find out which one. We know ADB. That is 140. Now we are going to find out this reflex angle of AOB. This angle we are finding. Okay. So to find out that angle, we know we have came across one theorem. I gave you already that statement. Relate to that statement, we'll write down one equation. What is that? That is ADB. Related to that statement, we can write down one equation. What's that? Let's see. That is angle AOB. This is a reflex angle. Okay. This outside angle we are finding. Okay. So AOB will be twice the angle which is formed on the circle. That is AD. So twice of ADB. ADB is how much? 140. So you will get it AOB as how much? 280 degree. Okay, but that is a reflex angle. What is reflex angle? Angle lying above. That is 180 between 360. That is what we call it as a reflex angle, right? Okay. So, but we needed the interior, not the reflex one. So now we are going to find out this one. This AOB we are going to find out. Okay. Now how to find out the inner AOB? Okay. So we have for that one same what to do it. That is AOB is equal to AOB is equal to 360 minus exterior angle of AOB is almost 280. We have to subtract it with the total angle. So why we took it 360? Because the circle whole angle is 360. Because at the center of the circle that is O, and the central angle of the circle will be almost 360, right? So we are subtracting 360 minus 280. We'll get the value as how much? 80 degree. We got angle AOB as 80. We got AOB. Okay, but in the question, they did not ask us to find out AOB. They're asking us to find out OAB, right? OAB. Let us erase this all. We need it. Which angle? AOB we got it. That is how much we got? 80. We need this two angle. This angle. As you can see, OA and OB are what? Radius. What they are? Radius. Okay, radius will be equal of a circle. Okay, and an angle opposite to this radius. That means radius are what? The side of the triangle. Okay, so these two sides, that is OA is equal to OB. Now, which are the angles opposite to equal side? That is angle B and angle A. Let us give the name angle B. How we can write down? OBA. Okay, and opposite angle of OB is what? OAB. Okay, these two angles are what? Equal. Okay, let us use the same thing here. The first one, we can see the triangle is formed at the center. So one is the angle AOB. AOB plus AOB plus other two angles are one is OAB plus other one is OBA from the figure. Okay, is equal to 180. This is the property of a triangle. Interior angles of a triangle will be equal to 180. AOB we know that is 80. OAB and OBA both are equal. So OAB we're gonna write down as it is. O in the place of OBA, we're gonna substitute what? OAB. Because we need to find out the value of OAB, right? Is equal to 180. The next step, OAB we can write down twice of OAB, transpose 80 to the right hand side, that becomes 180 minus 80. So twice of OAB is equal to 100. So cross multiply. So OAB is equal to 100 by 2. So finally, OAB is equal to 50. That is the final solution for this question. Hope you have been clear with the explanation. If anywhere at any moment you are feeling doubtful, just comment your doubt. We're gonna give the explanation for that step once again. Thank you all for watching the video.